In this session, let us understand the types of lubrication. Hydrodynamic lubrication. Hydrodynamic lubrication means the load carrying surfaces of the bearing are separated by a relatively thick film of lubricant so as to prevent the metal to metal contact, and that the stability is obtained can be explained by the laws of fluid mechanics. Hydrodynamic lubrication does not depend upon the introduction of the lubricant under pressure, though that may occur, but it does not require the existence of adequate supply at all times. The film pressure is created by the moving surface itself pulling the lubricant into a wedge-shaped zone at a velocity sufficiently high to create the pressure necessary to separate the surfaces against the load on the bearing. Hydrodynamic lubrication is also called full film or fluid lubrication. Hydrostatic lubrication. Hydrostatic lubrication is obtained by introducing the lubricant, which is sometimes air or water, into the load bearing area at a pressure high enough to separate the surfaces with a relatively thick film of lubricant. So unlike hydrodynamic lubrication, this kind of lubrication does not require motion of one surface relative to another. We shall not deal with hydrostatic lubrication, but the subject should be considered in the designing bearings where the velocities are small or zero and where the frictional resistance is to be an absolute minimum. Elasto-hydrodynamic lubrication. Elasto-hydrodynamic lubrication is the phenomenon that occurs when a lubricant is introduced between surfaces that are in rolling contact, such as mating gears or rolling bearings. The mathematical explanation requires the Cartesian theory of contact stress and fluid mechanics. Insufficient surface area, a drop in the velocity of the moving surface, a lessening in the quantity of lubricant delivered to a bearing, an increase in the bearing load, or an increase in lubricant temperature resulting in a decrease in viscosity, any one of these may prevent the buildup of a film thick enough for the full film lubrication. When this happens, the highest asperities may be separated by lubricant film only several molecular dimensions in thickness. This is called boundary lubrication. Selection of lubricants. Selection of lubricant based on following parameters. Operating environment. The environment in which the lubricant must function, generally that is the temperature range of the application. Sometimes other environmental consideration like outer space, liquid oxygen, or other reactive medium. One must decide which type of lubricant is required for the application. Viscosity and fluid film lubrication. The low temperature operational capability of a liquid lubricant is defined by the maximum viscosity at which the lubricant can be pumped. The high temperature operating capability of a liquid lubricant may be defined by minimum viscosity that can provide fluid film lubrication. The lubricant has to be effective in both the fluid film lubrication and the boundary lubrication regime. Boundary lubrication performance. When metal-to-metal contact occurs between two surfaces in a lubricated contact, the asperities on the surface shear thereby exposing a fresh metal surface. The appropriate lubricant reacts with the exposed fresh metal to form protective surface films. The surface films thus formed are generally low friction and wear resistant, and protect the surfaces from early failure or wear. Anti-wear or lubricity additives are generally added to the base oil to enhance the formation of protective surface films during boundary lubrication. Stability. If the upper operating temperature limit for a liquid lubricant is not defined by the viscosity temperature properties, it is generally defined by stability of the lubricant. A lubricant must be stable in the environment in which it is being used so that it provides adequate lubrication for the finite lifetime. Fire resistance. Liquid lubricants can range from extremely flammable to non-flammable. Fire resistance is extremely important in hydraulic fluids. Hydraulic fluids based on phosphate esters and synthetic hydrocarbons are in use to reduce the fire hazards in aircraft hydraulic systems. Compatibility. For a lubricant to be acceptable for a specific application, it must be compatible with all the materials with which it will come into contact. Biodegradability and toxicity. The biodegradability and toxicity have been combined because they both pertain to similar characteristics of lubricants. The degree of biodegradability of a lubricant relates to environmental friendliness of a lubricant, whereas the toxicity of a lubricant relates to the friendliness of the lubricant to the user. Biodegradability is becoming a more important property as environmental regulations become more restrictive with regards to protecting the integrity of water supplies and environment in general.